Welcome to another episode of Design, Develop, Share. My name is David Anderson, and today we're going to talk about the decorator pattern. And we're going to do some interesting things. So, the decorator pattern is actually probably my most favorite design pattern there is out of the Gang of Four patterns, maybe of all time. And the decorator pattern has a very unique thing that it does for you in your program. And so basically, if you have the need to add behavior to objects at runtime, and maybe many kinds of different behaviors, and maybe aggregate them together in a composable way, the decorator pattern is actually really great for that. And usually you'll end up finding the need for the decorator pattern when you realize that you have the need for multiple inheritance, or an inheritance model just doesn't get you what you need. And you can simulate multiple inheritance with interfaces, but it's not the same thing, and you can't share code and in the same way that you could otherwise. So we're going to show you the decorator pattern, and that's kind of the reason why you might use it, but we'll make this make a little more sense. So we're going to switch over to Visual Studio, and we're going to write some code from scratch, show you basically how to implement this pattern, and maybe come up with a good example as we go along. Because I don't have anything, we're just doing this on the fly. And by the way, a good example of the decorator pattern is actually streams. Stream objects in .NET. I'm just going to create a basic stream here. And yes, I'm using my mechanical keyboard, so it might be a little loud. And I'm in a .NET Core app, so let's actually create a file stream. And it really doesn't matter for me to show this, so we're just going to go ahead and do this. But if you've ever used any kind of stream, and let's say you've ever used a buffered stream, you'll notice that it takes another stream as a parameter. That's one sign of the decorator pattern. The second sign that you can look for is that buffered stream will actually also derive from stream. So that is probably one of the easiest ways to identify if you are actively using the decorator pattern on something that an API that might already exist. Is typically you'll have some type of object that you're using, and you'll create some other very similar type, and they both derive from the same base class stream, and it'll take the more general stream or object as a parameter. And basically what it's doing is it's wrapping that stream object, and because it derives from stream, that wrapper has the same public API service at its core. Now, a buffered stream obviously might add new properties and methods or behaviors and things that you might not even know are going on just by looking at it on the surface. But that's how the easiest way to identify the decorator pattern. So we're going to show you how to implement that in a few different ways. I'm going to show you how to first implement the basic pattern without doing anything fancy, just the bare bones pattern. And then I'm going to show you how to better implement that pattern in a way where you don't run into some of the common gotchas with the pattern, because the pattern can actually be fairly difficult to implement correctly, especially when you're dealing with types that have private or even protected members. The pattern can prove to be challenging or questionable, and so we're gonna go talk about that. So we're going to add, first off, we're going to add a customer class. So I'm just going to, a lot of people, if you look on DO Factory or other places that have design patterns, people like to use pizza with pizza toppings, or coffee with cream and milk and sugar and basically various ingredients. I don't want to do that. We're going to try to do something a little bit more concrete that people can relate to, and something more concrete is customers. Almost any software system has some kind of customer or user. And like I said, we're doing this on the fly, so it really doesn't matter. So we have a base class customer. Here that is there. And let's say our customer does something. So customers typically have a name, and we're going to create a basic constructor for this as well. So we're going to basically give the customer a name. I do use ReSharper for those of you that maybe are watching my videos for the first time. So a lot of the keyboard shortcuts I have or the code generation will come from me using that. I get a lot of questions about that. Okay, so we have a name, very straightforward. Let's also do something, for example, we need something that we can act upon and change. So let's say a customer has a balance. That's a pretty easy thing to talk about. And let's say that customer, we can do something on that customer. We want to be able to take some action on it, have some kind of behavior. So let's say set balance, or actually let's just even call this purchase, and we'll say amount. And who cares what we're purchasing? This is just an example. But let's say that the fundamental logic for this is that we're going to simply add the amount to our balance. And that's what the purchase method does. So extremely straightforward. Now, if I were to want to create different kinds of customers, I could derive from this and create a super type. And so if I was to say, so now we're going to expose the need for the decorator pattern. So I'm going to say public class bronze customer, right? So let's say I'm a Best Buy Awards member or something, and I'm a bronze customer. And I derive from customer, and I know that I'm going to need to implement that base functionality by passing down the name. And let's say that in that bronze customer, I want to override the purchase behavior, right? And so I can make that method virtual, and I can override that method. And let's say, just for the hell of it, a bronze member always, whatever you're purchasing gets a $1 discount. And we're not going to add any validation logic or anything like that, because for the sake of showing the pattern, it's irrelevant and we don't care. So a bronze customer does something different. So let's go ahead and use those two things. I'm going to say Bob. All right, well, I guess we could use my name. And I'm going to make a purchase for $50. And we're just going to print that to the console window. So we're going to print this to the window. And let's go ahead and just write a new line there. Nothing special. We'll run that. And now you can see we got 50. So now let's say I want to be a bronze customer. So now we have an inheritance situation here. So I can't just take that customer object and turn them into a bronze customer. I literally have to create a new customer object to do that, and then copy over the property value. So we're going to basically do that. And here, again, I have to literally copy that. I can't just extend my original customer object, and that's kind of the thing I want to do. But we're basically showing the initial attempt at inheritance. So then I can say And maybe I need to also copy over that customer's balance, right? So we need to do that first. And then we're basically going to do the purchase through the bronze customer. And we're going to do the same amount and output that, right? And now we should get an output of 49 because we said that a bronze customer always gets a $1 discount. So now we have a value of 49. So the problem then comes into if I want to add even more kinds of behaviors to this, like maybe I have a bronze customer as a certain kind of attribute, or I can assign to a customer as part of my shopping app or my website. But that maybe I also have something like a VIP customer. Maybe you can be both. Maybe you can have a bronze status and a VIP status, right? And you can kind of start to see where this gets difficult. We only have one property right now called balance, and we have one method called purchase. But as your customer object comes to a point where you have 10 properties, 5 methods, and now you want to start tying all this logic together, inheritance doesn't work really well, because then you also run into situations that, does your VIP customer derive from bronze customer, or does it derive from customer? Does bronze customer derive from customer? And maybe you want all these things to be combined. And the inheritance model in C# without multiple inheritance only really allows you to do one of those things, not both. So then there's the need for potentially the decorator pattern. And again, these are behaviors that we want to do at runtime, not at compile time. Inheritance is a compile time concept, whereas the decorator pattern, I'm writing all this code at runtime, which means I can also write conditional statements to check, maybe if the customer has a $0 balance or a very low balance, and maybe they have a really good history with the company. They made purchases for 10 years. Based on that criteria, I might have something like, age is greater than 10 years. Then I might associate them as a VIP customer. And I want to be able to do that at runtime. So what we're going to do is actually implement the decorator pattern instead. So now we've established some concept. So the way to do this is it's still kind of done through inheritance. The difference is, instead of overriding the base purchase function and assuming that the balance will be passed in and the name will be passed in, we're going to actually pass in a generic customer. And this can be any customer or anything that derives from customer. And what we're going to do is add that as a private field. We do need to pass still that customer's name, just because the base class constructor is going to require that. And we'll get into a few things here in just a second. And then what we're going to do is create a decorated customer there. Now what's happening here is this balance property on the bronze customer still is not the original balance property of this guy. And so the decorator pattern, basically we need to be able to override the balance property and redirect its get and set methods to the decorated customers method. And that's what kind of creates it as a wrapper. So we need to make balance virtual. We also need to make name virtual because we need to do the same thing. So when you're using the decorator pattern, it's very common that you're going to need all these to be virtual, including the method. We already had that. And what we're going to do is then override balance. And what we're going to do here instead is actually get the decorated customer balance and set the decorated customer balance. So again, we're redirecting the bronze customer get and set to the customer passed in. And we're going to do the same thing for name. So we're going to override name. If I were to just say get and set and not do that, then basically I would be having two distinct values of balance. I would have the balance of the bronze customer and then I would still have a separate balance for the original customer passed in, and we really just want one balance. And in our purchase method, we want to manipulate that original customer's balance, but just in a different way. So what we're going to actually do is, instead of saying base.purchase, which again would actually indicate we're going to have a separate copy balance, we're going to actually say decorated customer purchase amount -1. And so the thing you need to realize about the decorator pattern is you're not trying to modify or override private implementation details of the original customer, or even protected details. What you're trying to do is add additional behaviors in the order you want, to a degree, to an already existing public API. And you're not even trying to change that public API. You want the original public API to work exactly as intended. You just want to do something else or manipulate it very minimally. I don't want to override it and change the implementation. I still want that to work. So the coffee example that a lot of people use, you still want to start with a black coffee. I just want to add sugar to it, but I don't want to change the way that coffee was brewed, or how it was made, or how much coffee was produced in my coffee cup, 6, 8, 10 ounces. But I might want to add some sugar to it. So I'm not trying to change the original implementation. I'm just doing something a little bit different, but still utilizing that implementation. So the effect of that now is, if we come back in here, let's go ahead and erase that. And let's set our customer balance. Well, let's just leave that at 0, because we're going to make a purchase again. So we know their balance starts off at 0. So now I'm going to say bronze customer, except this time we're going to pass in the actual customer object. Okay. And we're going to operate on this customer. I could still make the purchase as just a regular customer and make a $50 purchase, and their balance will still be $50. Instead, I'm going to operate on that same customer as a bronze customer and do the purchase that way. And we're going to give it the same exact value of 50. Right? But now you're going to see something interesting. I'm going to actually come down here and change the output from bronze customer to customer, and we're going to go ahead and run this. And what you're going to see is our output, if I did this correctly, so we actually need to, right. So you have to be very careful with this. So we do have to change the implementation of the base constructor. We have because we made that virtual, this is going to call the overridden version of name. And so we actually don't want that. What we're going to do instead is create a private field. To do this, we're going to say this name equals name. And then we're going to come in here and make the base class property, store that in a field. So that way we're not accessing a virtual member in the base class. So you got to be very careful with that. We could even potentially do the same thing with balance, but in the case of balance, we're not calling it from the constructor. So there's no, that issue is not there. And it will have a private field that gets stored in. So when we say base customer name here, that'll solve that problem. The base class will in fact store the name in the variable, but the overridden method will work off the decorated object, which ultimately is still that same field at the end of the day. So we're going to go ahead and run that now. And now what you can see is our output is still 49, right? Which is what we wanted. Now what we can do is set a breakpoint on line 17 and run this again, just so we can observe what the decorator pattern is actually doing. So we had a customer with a balance of 0, and then we created a bronze customer to decorate that customer. So we're still working with the David customer. So if I actually look at bronze customer, my name is David and the balance is 49. And if I look at customer, we should see that the balance is 49. That's the coolest thing that the decorator does for you. Now what we can do is we can come in here and we can start adding all kinds of different things. So I can now add a VIP customer. And again, we're just going to operate on the base customer class. We're going to actually just copy all this from our bronze customer because it's basically a very similar template. You always want to work off the base most class if you can, unless there's a reason for you not to. Maybe you need to decorate a more derived version of customer. So in this case, we're not going to really change much of anything, but let's say for a VIP customer that their balance or when they purchase something, we're going to do something different. Maybe they get an additional $4 off. And so let's say the idea is if you're a VIP customer, that also means just for the hell of it that you are a bronze customer. So you go from bronze to VIP. And maybe when you become a VIP, you still get the benefits from the bronze tier, but in addition to the VIP tier. So we basically are saying in that case, we still want that $1 discount to apply in addition to the $4 for a total of $5 for a discount. Now there's some things we can do. And maybe we want the flexibility to say that not all VIPs are bronze customers, right? Maybe there's other circumstances in the system. So to show the cool thing, the flexibility of the decorator pattern, let's go ahead and create the VIP. And I can pass in my bronze customer, right? And then we're actually going to say VIP customer purchase $50. And let's go ahead and run that. And now we should see we have a balance of 45. So we had the $1 discount that applied. We had the $4 discount that applied. Now, what if I don't want in my shopping cart app or whatever, my store, maybe I don't want a VIP customer. Maybe there's certain circumstances where they don't get both bronze customer benefits and VIP customer benefits. Maybe at one point in time, that was an option and people are grandfathered in to that situation. But maybe now, too bad, so sad, you only get the $4 discount and no bronze benefits because maybe the business decided that's too much. So in this case, we're just going to pass in the regular customer instead of the bronze customer. And we're going to make that purchase. And we should have a value of 46. So we didn't have the benefits of the bronze package applied. And so you can see that I could have passed in the bronze customer or just a normal customer. So the decorator pattern, you're seeing how we can implement something as powerful as inheritance, but more powerful in the sense that I can combine many different behaviors together. So I don't have the option of multiple inheritance, but I can also write at runtime a lot of if conditions or logic to determine what kind of decorations I apply to my objects. So that's the really cool thing about the decorator pattern. I found the decorator pattern is really nice for business layer classes where you need to have lots of different behavior for business objects, and inheritance just becomes too complex to manage those behaviors. And again, it applies to both properties and methods, basically the things you can override. So that's really cool, but there are some challenges that come with the decorator pattern, and let's actually talk about this. So let's say for instance that there is a protected member on the decorator object. So let's create a protected member, and let's call it I'm going to create this as virtual. And let's call this clear balance. And let's say that we just set it to 0. Straightforward. So that's a protected member. And let's actually make sure that's on the base class. So all the way down to customer. Now, I can, from within this base class, access that clear balance method, right? And there's nothing wrong with that. And that'll clear the balance out to 0 like I want. And if this was just deriving from customer and I was not using the decorator pattern, that wouldn't be a problem. But the problem that the decorator pattern has that makes it difficult to know, should I override this and redirect it to the decorated object, or can I? Or maybe you want to and you can't. So if I go into our bronze customer, I can override that function. But because it's a protected member, I can't access that on the object I'm actually trying to decorate. It's protected. So I can access the base class one, but that doesn't do anything because we're not in the traditional inheritance model. We're trying to work off the already existing public APIs and values of the object we're decorating. So customer. So, and maybe I don't even intend on clear balance being a extendable method. But the problem is I can access it, I can override it. And when you have the decorator pattern and you have, again, 5, 10 properties or methods, it's not then clear which ones you should override, which ones you can override. And there might be situations where you don't have control over that API and maybe you want to decorate it, but too bad, it's not public. You can't. So there's a way to kind of solve that to make your API a lot more clear, and that's to actually use an interface. Now, this only really works really well when you actually own the code for the base class. And maybe it's a design choice for this to be protected intentionally. You don't want people to access that as a public API, so that's fine. But you don't want people to be confused when they're decorating that object either, right? You don't even want them to care that that's there. So the best thing you can do to improve that shortcoming of the decorator pattern, and you'll see a lot of places recommend this, is to use an interface. So what we're going to do instead is extract an interface. And what I like to do is actually call this as it is, iCustomer, or you can actually call it a decorator if you want. And you can have multiple interfaces. Maybe you have an iCustomer interface and an iCustomer decorator interface. But let's just call this iCustomer because we don't really want to name our classes after the pattern. That's usually a code smell. But so let's basically, we have a name, right? So let me actually not do that. So we have a name, we have a balance, and that's we have a purchase method, right, with an int amount, and we can go ahead and just implement that without any coding changes to our base class. And because a bronze customer derives from that, it'll implicitly have to implement that interface as well. But the thing we're going to do differently now in our decorator pattern is instead of taking the concrete object as a constructor parameter, we're going to take the interface. And so the interface is basically now we've clearly defined only the things that we can decorate. And we also are going to derive from the interface instead of the concrete class. So now the thing that we get to do is we don't actually have to override those methods. We can just implement them. But now we don't have access at all to the clear balance method, which is great. So now our decorated object is much more clear in its intention. And I still can't access that, which is great. So we've basically reduced the API surface to only what we want to be able to be decorated. And again, in this case, there's no base class constructor, which is actually even better because now it's not so confusing as whether we're utilizing base class functionality versus the decorative functionality. So that kind of solves that problem. So now we have a really nice, clean decorator object. And we would basically do the same thing for the VIP customer because we don't want any of that confusion there either. And again, we can get rid of the base class constructor. And now essentially, we are only exposing the public API in our decorator objects. We don't have to worry about any base class functionality because that just makes it too confusing. So we still get the same code over here. It doesn't change any of this at all. So if we were to run all this, we're going to get the same behavior we'd expect. Our VIP customer that decorates our normal customer gives us a balance of 46 on a $50 purchase. Or I can revert it back, or we do that on a bronze customer and run that, and we should get a $45 balance. So we didn't lose anything. We gained simplicity. The one thing I guess you could say we lost is complexity. So my recommendation with the decorator pattern is pretty much to always use an interface unless your base class doesn't have any of those concerns. But oftentimes you'll find that you end up having those concerns whether you like them or not. And so it's best just to have an interface anyway. You do end up with a lot of class interface pairs. So, customer and iCustomer. But there's nothing wrong with that. I have projects where we've got 50, 60 objects. 30 of them are the actual concrete types and the other 30 are interfaces. There's nothing wrong with that. It makes your code base much more understandable. Now there still is the case of I still might want to derive objects from customer and not use the decorator pattern in conjunction with using the decorator pattern. And that's the cool thing about this is you're not forced into any one scenario. You're not forced into inheritance and you're not forced into the decorator pattern, and they both work well together. So if bronze customer was just a traditional class that derived from the customer super type, I could still decorate it with the VIP customer and there's no issues. So you can mix and match. So you can kind of see the value of that pattern. So that's the decorator pattern. I hope you enjoyed that video. It might have been a little long-winded, but modifying objects by adding and extending behavior with other behaviors at runtime. That's the key. That's why you want to use the decorator pattern. When inheritance just doesn't do it, or inheritance, the model becomes too complex for your needs, the decorator pattern is a very cool thing in your toolbox. It's not an end-all solution, and you can do some crazy things, and you can make your code base very complex with the decorator pattern. But when used right, it is probably one of the most valuable patterns that exist out there in my mind. And it's also why it's one of my favorites. I've created an entire business layer for an enterprise app with an extensibility model based on the decorator pattern. And that extensibility model was basically, we have a code base and with a customer object, for instance, and that customer object needs all kinds of things that can happen to it based on feature modules. So we have feature module A, B, C, D, E, F in this enterprise system. And customer is kind of the core concept of this system. And I don't want all the code from feature module A, B, C, D, E, F in that base class. And I also don't want, at some point, the inheritance model doesn't work. I can't necessarily, feature modules are often horizontal and not vertical, meaning I can't necessarily derive a customer object in feature module F from E, from D, from C, B, A. That doesn't work. Not all customers might have all feature modules. And I might need to mix and match depending on what I'm doing in the application. So the decorator pattern allows you to solve that kind of problem. And so I used it when I designed that business layer, especially in terms of feature modules. It was a really cool thing. It also allows you to only pull in the code that you care about depending on what you're doing. So I could write some code to say if the customer has this module, then I know it's safe to use the decorator objects on my base customer class. If they don't have the feature module, I know I don't have to use those objects. But if all that was baked in to an inheritance model or in that base class, that gets really hard. Other ways you could solve it are by not using the decorator pattern or not using inheritance, but by using lots of other business objects or manager objects or service objects that tie all that business logic together. But I found the decorator pattern is more of a natural fit for that, where I truly want like a customer, and then I want an audited customer with audit tracking, for example. And I don't necessarily want and so what I want to happen is I want audit tracking to occur whenever I perform actions on that customer object. I don't necessarily have to want to necessarily manage a whole bunch of other audit objects and things like that. I want to call customer.purchase and then make an audit. And I want that to happen automatically just through the decorated object, based on whether they have the feature module or not. So that's the decorated pattern. If you liked this video and you found it helpful, definitely remember to like the video below, hit subscribe, share it, and we'll see you next time.